Hey, Matt, I think you're on mute.
Yep. Off to a great start so far. So, if you didn't hear me doing the intro, welcome everyone. So, um, we are three folks assembled today from CAI, myself, Matt Geffken, our Chief Product Officer for CAI, along with Matt Radford and Andre Lillebakk. Their faces are up at the top of the screen here. We'll all be talking and covering various different sections, but Matt and Andre are both experts. They're in the field today, working with customers, clients, deep in the weeds. You couldn't have two more esteemed, knowledgeable guests to be walking you through some of this. So I'll be a bit of your MC, and just I want to level set on a couple of ideas, definitions, things like that to get us started, and then we'll be handing it over to the team. So I still don't have access to advance the screen. So Tori, if you could just move it for me here. All right. Bit of housekeeping for everyone. The chat function is on. We'll be monitoring it. By all means, if you have questions, please ask. And if it's appropriate, we'll break stride and we'll talk about it during the session itself. Otherwise, we'll just pull them at the end and we'll answer some questions there. All right. So just a quick, who is CAI? CI, we are purpose built to create actionable information for our customers. We have a really wide portfolio of products from ERP system, just about every acronym in the industry. We have a solution that kind of addresses it, but our big focus is around manufacturing, processing, and distribution environments. But we do a lot of things around process improvement and just general streamlining in that space. We've got a lot of diverse customers producing everything from rocket ships to toilet seats to a lot of food and beverage. So we've seen a lot, and we've got a lot of folks with many decades of experience that love volunteering in situations like this, and also helping our customers implement and use our software. So IIoT, we define it, and kind of a generally accepted definition of IoT is around really the application of internet connected sensors and devices. It's a bit of a nuanced difference between IoT and IIoT, but we want to make sure that we're kind of clear on that same page around what we actually mean when we do say IoT. So we've got a couple examples here. If you look at kind of on the left side, a smartwatch, and kind of the analog to that in the IoT sense would be just a giant optimized production line with timers sensing how optimization should work over there. You have your connected washing machine on the IoT side, but think about how all those washing machines or other robots kind of work in circuit with each other on the IoT side. A thermostat versus a full energy grid optimization. So you can see it's about scale, it's about multiple connected devices kind of working together within an industrial setting to make this come together. So IoT in the real world, it's not some futuristic concept. It's here now. It's driving tangible value across the industries. The folks on this conversation today are experts in that, but really what our focus is on making a lot of these industrial operations safer, faster, greener, and more resilient. So we have a couple of trends, predictions, things. A lot of these are things you might know, but AI integration, that's coming. You can't stop hearing about it on the news. Predictive maintenance, sensors, reducing maintenance costs 10 to 40% based on data kind of we've seen experience on flexible supply chains. So, real-time inventory, being able to see what's kind of coming around the corner, be able to control demand forecasting, reducing storage costs, and boosting customer sat. And then, of course, Industry 4.0. So combining IoT, AI, 5G, bringing it all together, making devices, humans, everyone working in concert together, solving problems in industrial settings. we play in that space. We have all sorts of products, offerings, services, and even hardware to support all this. Andre.
Yes. So IoT, actionable insights. So the industrial Internet of Things connects machines and sensors and systems to deliver live actionable insights. Instead of relying on guesswork or manual checks, manufacturers gain full visibility into the equipment health, performance, and process deviations before they become a problem. So you often say that without data, you're flying blind, but with IIoT, you see the full picture and you can act on it. So we have some real life examples as well. Linsight IoT connects today and supports 11 energy companies, enabling approximately 7,500 energy transformation stations spread around a country to communicate together in real time. This allows the utility providers to identify usage patterns, detect anomalies, and optimize the performance. In addition, it also helps the companies to utilize the existing infrastructure in a more efficient way, and it reduces their waste and delaying or avoiding the need for expanding the grid, building new power lines, and have costly investments. It's a clear case in how IoT can unlock a smarter, more sustainable operation without physical overhauls. And this we have been doing for many years now, and it's a proven platform. Yes.
Okay. So now that we have to click a couple of times here, Tori, to get through it, but thanks, Andre. And just to give some context to what manufacturers are struggling with today that we see with our customer base and with customers that we interact with, it's really a lack of accessible data. So you have data in your ERP, MES, homegrown systems, machines. How to get to it is really where the challenge lies. You click again, please. And so there's a few different areas that you see the impact, right? The first, obviously, that's what's, widely talked about is you need to know what your machines are doing. Are they up? Are they down? Are they utilized? But it gets a little bit deeper than that when you integrate with different systems and start to really pull meaningful data from connected tools and equipment. But you can help with inconsistent quality, bringing measurements in that previously existed on paper. And as a result of not connecting, your true root cause analysis requires a lot of legwork, boots on the ground, people walking around the factory, pulling papers, pulling files, maybe doing VLOOKUPs in Excel sheets, however you guys need to do what you need to do when issues occur. But it's a lot of waste. It's a lot of time. It's a lot of cost. And at the end of the day, it usually ends up with frustrated customers through late deliveries and such. It's not just customers that remain frustrated. The frustration can also exist within your four walls. Um, Operators, for instance, that are running an assembly cell where a sensor consistently comes out of adjustment, and every several cycles they need to reach in and adjust it. It's nice and quick, it's simple, it's easy, but it's something they're working around, right? They might complain to their peers about it, they might tell a supervisor, but oftentimes it just becomes part of their process, which makes things take longer, contributes to their frustration. And without true data and transparency and looking at things through a single pane of glass, it's very difficult to bring those things to the surface. And thus now you're in a situation where you have frustration internally and frustration externally. So how come we just haven't plugged everything in and connected it already? And there's several reasons, and I'm sure many people on the call are encountering within their own organizations. One, you have people, and that could be perception, that could be belief in what's possible, it could be what their current knowledge extent is, and just people in general. The other is processes, how you do things, why you do them that way. Multiple equipment vendors, unfortunately or fortunately, in manufacturing, you have machines that run for 30 or 40 years. Well, that's a different beast than a modern piece of equipment that comes fully outfitted with APIs and the like. So systems not being able to talk to each other, variation in people, processes, and equipment all contribute to really having no central visibility of your factory floor. So why? Well, like I said, old machines, newer machines, everything seems to speak a different language. Depending on the protocols that they use, it can be very difficult to connect. You could have a vast array of things that you need to decipher in order to get meaningful data out of your equipment. There really isn't a standardized interface between them because they're all disparate, siloed pieces of equipment. And when you do bring them together, oftentimes you end up with a large amount of consulting or professional services work that can be quite expensive to tailor just the needs of the thing that was set up or to bring the data in that you actually need. Sometimes you can't get real-time data. Sometimes you bring it in chunks or over a delayed amount of time and you're not looking at what's happening today. And not having visibility into machine level events contributes to a number of inefficiencies across your organization. So how do we solve it? So the biggest thing is bridging that data gap, being able to continuously collect data, but also integrate that data into how your people and how your processes are performing. So let's just use MES as an example. If you're collecting data from a temperature sensor on an injection molding press, you might be able to better predict the outcome of scrap or defects or non-conformances. Um, that data lives in the machine, but when you're connected and you're feeding the MES, you're able to merge that data together and analyze it in a way where you can make those connections. You can also automate workflow triggers. So things like recording the quantity off of a piece of equipment that automatically will trigger a label print when you hit the standard pack of your orders is something that's entirely possible once you do that kind of integration, as well as recording critical quality inspection data, process data, maintenance data, and the like, without people needing to be involved or writing it on paper or putting it into a spreadsheet. And there's also closed loop feedback that can occur. For instance, an operator detects a defect at the end of their line and says, I have a scrap for reason A. Well, reason A is a critical scrap choice, so we can actually tell the PLC to stop the machine because this has been detected by the person. So it really makes everything work together in an orchestrated way in line with how your business processes need them to be. And ultimately, at the end of the day, now you have a unified platform, a unified pane of glass where everybody's working to immediate information, single source of truth, and those delays that you see in getting to root cause and people running around collecting pieces of paper, it goes down significantly. So I gave you a couple of examples of what would happen if, let's just use MES as an example, where you're tying in the machines and the equipment and the tools your people are using. If you just switch to the next slide, you'll see some of the benefits, right? And like again, predictive maintenance is one we've touched on. It's pretty prevalent. Everybody wants their utilization, and people are generally trying to predict when their machines go down. The automated quality checks and alerts are an immediate reaction to information that's affecting the critical characteristics of your part and getting the right people involved right away. But one we didn't really touch on here is the dynamic scheduling, and this is coming up more and more with our customers and in the industry, but because manufacturing is a diverse and challenging environment where things go up and down and projects change priority and quality issues and people issues can affect how the flow from your plant will go, being able to react to the information, to the uptime and the downtime, move jobs around, move people around, prioritize things that you have the material for, put the right people on the right jobs based on their performance. This is sort of a big benefit and where a lot of our customers are starting to focus their attention. with that, I will turn it back over to Andre for some more real world examples.
Thank you. And what we see today when we're visiting factories around the world is that, as Matt Radford mentioned, manufacturing equipment, they'll last for many years. And over the years, when you're acquiring new machines, at the end in the control room, you're ending up with maybe 20 different logins to the different equipment suppliers, different kind of machinery. It's very difficult to get a good logic overview between the machines and why is this machine stopping? Is it cause of something on the other machine? Is it a common error that comes many times? And this could be everything from camera surveillance, it could be stamping machines, molding machines, it could be ice cooling systems, it could be even building automation and ventilation, cooling, public energy, could be public data sources, and a vast amount of other data. What we do is to help to integrate and make all these different systems communicate both together and also into a centralized system. So when we connect, utilize Linsight as a connectivity to your different kind of equipment, we integrate them together to on common generalized source and also make it available so it's much easier to integrate those machinery again with MES systems, ERP systems, it could be other third-party system or analytics services, whatever you want to integrate it into, either between the machines or also to other third-party systems. So this helps you to get what you see on the right side instead of the left side with a more one user interface, uniform in a standardized way. So it's easy to see how a thing's happening cross machines, vendors throughout your production line. This is based on standardized cloud solution, but also it can run on-prem and it's a redundant solution. All the data we gather then in the solution is also shared to the analytics database. So you can utilize it either with your own analytics services or with CAI's analytics platform, of course. And after people has connected all the machines and got the machines to connect together, made their own logic to this happens when that machine stops, then the other machines stop. After that, we see that a lot of our customers want to implement alarming services that we have. So we like to call it a one-stop shop for alarm monitoring and handling. And this is instead of getting a text message with B05 fault from one machine and some other cryptic message from another machine, or maybe email for the third machine, you centralize everything. So you have a one common source of truth for all your alarms. In addition to that, you could set up both a scheduling for who should receive the alarms and a hierarchy so that right people get the right alarms and critical alarms escalate if the technician that's acquired the alarm doesn't respond to it. So this helped them set up a very scalable structure to ensure that you get alarms, either if it's in text message, it could be emails, it could be push notifications, or even for the most critical alarms, voice dialing. We use this in real-time factories like this one, for example. Here we have a generalized production plant where they have implemented raw materials so that Linsight is tracking what they have available for raw materials. We then are making a plan shell for them in cooperation with both the ERP system and the MES system so that we help them to make, based on their sales from ERP, we forecast what is the best return of investment for your production capacity of the upcoming days for utilizing the production capacity you have the best way. And based on what the customer then approve, we start up the factories during the night, so it's prepared and ready for them to start running in the morning. During the production day, we are monitoring each step in the production. As Matt Radford mentioned, we are tracking each quantity of the items, the quality of the items, all the scraps, the blood parts, and tracking them back both to the MES and also to the ERP, so that you have a full control of both the yields and all the parts throughout, harvesting the raw materials until finished packed goods on pallets, far right side here of the factory, and the packets is shipped to customers. In more simpler ways, if you have implemented just the connectivity part and you just need a SCADA solution, of course, that's possible as well as a more traditional SCADA system with more traditional diagrams, line charts of how things are flowing through the production line. It could be cooling, it could be water pumps, it could be whatever data source you have in a very good graphical overview, available both on iPhone, tablets, or whatever mobile device you have, or your computer or the controller in the other part of the factory. When we gathered all that data, we also see a lot of customers want to implement the, as I mentioned, CAI Analytics platform. So CAI Analytics platform is embedded inside Linsight as well, so that when you gain a lot of data from all this machinery, you could start to see trends. You could start to see, why is that machine on that factory operating at a higher yield than the other similar machine on another factory? You can start to put them together in trends and charts. We utilize here Power BI on top of Snowflake as a data platform, and it can give you very good and new insights into, why is this machine failing every Tuesday at 3? Why is that the root cause of it? And how is this performing with this shift team compared to the other shift team? So you could start to track and see trends and help to get new insights in how your best way you could utilize your production capacity. Yeah, this is just another simulation of the same insights on another way based on vast amount of data. Yes, and it's back to you, Geffken.
Yes, thanks, Andre. Yeah, and just for kind of folks on the line here, it's been super interesting working with both Andre and Matt. Andre comes to us via an acquisition we made in Norway, a company called Meritech, and they're specializing in seafood industry. And so the slide you're looking at here is a slide we like to use because it generalizes a bunch of cases. It deals specifically more with a consumer packaging use case, but our philosophy from development is, okay, you may have a product that's grown up in a certain industry and vertical, but we try to then generalize them once they're in the CAI portfolio to handle all different types of use cases here. So Andre's been a great partner for kind of taking the product that he was the founder of with this Linsight and kind of extending it not just for the seafood use cases out there, but some of the other ones that he showed in his examples, and then taking it a lot to what we do with our products that we've had in our portfolio for a longer period of time, one being ShopVue, our MES product. And we made an acquisition last year, Parsable. So they're a connected worker product and digital instructions, and seeing all of these products kind of come together now that they're under one roof gives us a ton of advantages because we can all speak the language behind the scenes and there's no concerns about data sharing and things like that. We can just make everything kind of happen because we're all one connected team together. But you can kind of see how all of these products, they play different roles at different parts in the process itself. The robotics one down there, at more the southern tip of the screen, is a great one we spent a lot of time on with kind of integrating and connecting MES with Linsight to handle some of the predictive maintenance parts and things like that. So just one specific example, but you can think about how this can be generalized to handle much broader use cases. Next slide. So kind of rounding things out for everyone, we just wanted to end with a handful of tips. We'll get into questions next, but some of our thoughts, if you are embarking on a project like this, or if you're in the middle of one and you're looking for support and assistance, and maybe it is time to kind of reset and reconsider kind of your approach to things. But we definitely recommend to not treat IoT projects as IT projects. Like, you want your end users in early. This should not be a thing that just, tech guys like myself are running the full program on. You want your users involved. This should be a kind of full spectrum, full team effort to move it across the finish line. A common technique we use in the product management side of things is building these, we call them story maps, to identify like the long backbone of every single piece within your ecosystem that a particular product would need to touch, or in this case, kind of an IoT project or piece component would need to be in your system. So thinking about putting together a checklist, but really illustrating all of your IoT devices, systems, people, and creating large scale checklists. We call them backbones kind of internally, a bit of a niche name there, but thinking more holistically about your entire ecosystem and thinking about making sure that you never kind of skip one or all the concerns are met as you are moving along in the process and the project. So that you don't miss out on something, whether it's an opportunity or a potential error or a quality issue down the line. Assessing your existing infrastructure, it's a bit of a no-brainer, but as you extend add-on pieces, make more connections between products, things like that, it's always time to evaluate, are you working with the best pieces of hardware and software in the process? Are there opportunities to upgrade, consolidate, things like that? And then, of course, choosing a solution with proven integrations. Certainly, we pride ourselves in having these proven integrations. We've been battle tested for quite some time. So obviously a little bit of a sales pitch there, but your whole project can rapidly fall apart if you're just having simple connectivity issues. Like, we're doing this because we want to get into the advanced concepts. If you're stuck in just connecting, then you can hardly work on some of the interesting parts if you're just stuck in the basics getting started. And lastly, like most projects, start small. Start with a proof of concept, a pilot, and then iterate on it, rather than go with a big bang approach where you've committed too many resources, time, people before you've actually checked on, hey, is this actually solving the problem we set out to solve? We like trying to find MVPs, smaller ways to prove an underlying thesis so that then we can iterate on it and make it better versus just kind of starting this in some sort of testing environment and waiting till it's all the way ready to go before it sees the light of day from end users and production floor. So there's some basic tips, and we do have a bunch of questions that came in along the process here. So I can read them out and our team can answer them. So how do we get started with IoT today? And do we need to invest in new machines to get things connected?
Yeah, that's a good question. I can try to answer that one. Maybe you too, Matt. But how do we get started with IoT today? Yeah, Geffken mentioned it quite good in the tips part here about starting small, scale it up, try to find your use case with the best return of investment, so you don't start on a big one and get stuck in the mud and never completes anything. And regarding the need for investing in new machines to get things connected, you can connect to most of the machines, but of course, as Radford mentioned earlier, it could be 40-year-old machines and maybe don't have any kind of Ethernet connectivity, so connectivity could be more difficult. But we have support for a vast amount of communication protocols. In addition, for the oldest machines, maybe you need to add on some sensors to get the information you like to have, but that's why we want to do some pre-studies and small pilot projects to identify that together with you as customer to find the most useful use case at your site. Hopefully that answered the question.
Another one really around like implementation times. I'm sure this is kind of context specific, but if you guys could just give some of your things you've seen based on different like complexities and styles.
That could be everything from the smallest IoT projects we've done is made in a couple of days of implementation, of course, for just small proof of concept. And these could be extended to maybe a year-long project when we, together with the customer, find out that, okay, we'll start on these parts. When this is completed, we move on to the next part of the factory, so we could prolong it for a good implementation period together with the end users and the company's capacity to implement it through their factories.
Excellent. All right. No additional questions that came in. So if you have one now, I'm not going to say it's your last chance, because of course you can just email us at the contact addresses that came back in the invite for this. We'd be more than happy to help with this. Myself, Matt, and Andre, we love doing this stuff. So we'd be more than happy to take your questions and help support you in any way we can. So we definitely appreciate the time. Hope it was a useful half an hour for everyone, and hope to hear from you soon. See ya.
Thank
Okay,
you.
guys. Thank you.